So today we're going to be doing 4.4, which is modeling and optimization. So in order to model and optimize, you need to have something called a constraint equation and an optimization equation. You're also going to need to typically draw a sketch of what we're looking at, okay? But sometimes, in this case, no sketch is really required. So it says to draw the figure, identify the equations, and then set the optimization equation derivative equal to 0 and derive. So, step 1, you have to determine the constraint versus the optimization equation. This is the hardest part, really. So, the constraint equation is going to be based on what the rules are, okay? And the optimization is going to be based on our goal, okay? Our goal is to figure out what the maximum product is. Does everybody see that? So our goal is to determine the maximum product of two positive numbers whose sum is 8. So our goal is to come up with an area problem. I mean, not an area, a product problem. Sorry, my thing's off. So the product of the two numbers could be represented by product is equal to x times y. Okay? So where x is the one integer and y is the other integer number. Now our constraint.
That's just saying.
It feels like completely different from what we were just working on.
Well, correct. What?
It feels completely
It
different.
is. You'll see where it comes into play. Just listen. Look. Okay. Just trust the process. Well,
When you just cube
yeah. Anything times itself, but we're not looking at area here. So why would we call it base times height? Okay. So, like I said, I know you could come up with this on your own. Okay, if you guys want me to start with hard problems as the first example, so you don't understand it, then I can do that if you want. Okay, so determine the maximum product of two numbers whose sum is 8. What does sum mean in math? So I know that x plus y has to be equal to 8. Okay, that's our constraint. So do you see the difference between constraint versus optimization? Constraint is what we're limited to. Optimization is what we're trying to optimize to make the biggest of. We're trying to make the biggest product of these two numbers, correct? Mm-hmm. Okay. So your goal now is to solve the constraint equation for one of the variables. It doesn't matter which variable. So I'm going to solve for y, which is going to give me 8 minus x. So everybody good with how I got that? Okay. So step 2 is to then take whatever you solved for and plug it into the other equation. So y is equal to 8 minus x. So it's going to be p equals x times 8 minus x. Okay? Everybody see what I did there? I just plugged it in. Now we're going to distribute. We get p equals 8x minus x squared. Okay? Your goal is to then take the derivative of this. What's the derivative of this? 8 minus 2x, and then your goal is to then set the derivative equal to 0. So x will be what? 4. So 4 is one of our integers, which means, of course, you can kind of think about if the sum is 8, the other integer has to be 4. But if you didn't think of that, you could also have just plugged it in here, right? And you get y equals 4. So what would be their maximum product? 16. So what that means is, if we think of numbers that add up to 8, like it could be 1 plus, if we think of numbers that add up to 8, yeah, it would be 1 times 7, 2 times 6, 3 times 5, 4 times 4. So you get the idea here. What's the product of 7 and 1?
7.
Good. The next one's going to be?
12.
Then?
15. 16.
Do you see why the math works there?
Yes.
So yeah, like I said, the reason I picked this example is I know you could have guessed and checked this and done it quickly, but it's to help you understand so you can look back and be like, oh, I can actually conceptualize what's happening here, right? Because it's simple enough. So that's the idea of optimization, okay? Now we're going to do an area problem. So it says here that a farmer has 2,400 feet of fencing and wants to fence off a rectangular field that borders a straight river. What are the dimensions of the field with the largest area? So what this basically means is if we have a straight river here, I guess I'll do it in blue. I forgot to change my color. So our river.
Mm-hmm.
And within that, we want to build a fence around that. So like basically this is like the river side, and then we're going to build a fence that is enclosed on the other 3 sides. So you see how the river acts as like the 3rd or the 4th side of the fencing? So it's like fencing off a rectangular field that's bordering the river.
So we're gonna have to actually like
Yeah,
look at the problem.
for
figure
sure.
out, like,
Yeah,
how many sides this thing has.
100%.
That
Yeah.
sucks.
What could suck a lot more is if I had put the volume questions on here, and the volume of a cone was one of the ones in the book. So
Ew.
Is that like?
can we just get through the lesson though? We don't need to have a sidetrack. Okay. So anyways, what are the dimensions of the field with the largest area? So what do we know about these 2 pieces right here? They're gonna be the same. So let's call them Y. And then this side is gonna be different than that one, right? Possibly. Which what can we call it? X. So keep in mind, we only have 2,400 feet of fencing. So what do these values have to add up to?
24.
Good. So X plus Y has to equal 2,400 because that's all the fencing we have. That's our constraint. We can't go any bigger. We can't add any more than that. We only have that much fencing. What's a more simple way to write this equation?
X plus 2y.
Equals 2,400. Good. Now optimization, our goal is to make this have the largest area. What would be the area of this shape?
X times y.
Just X times Y, right? Because the area would be determined by this times this. So we have our area. Now our goal is to solve for one of these variables. Over here, I'm going to solve for X by just subtracting over the 2y. So does everybody see what I did there? Now you're going to take what you know X to be equal to and plug it in for X in the area equation. So we got A equals Y times 2,400 minus 2y. So does everybody see how I've subbed in for X there?
Mm-hmm.
I just wrote it the other way around because it's just easier that way. But yeah.
It's easier to distribute.
Yeah, it just seems weird when the monomials.
Yeah.
So we're going to distribute. We get what?
2,400 y minus 2y squared.
Good. Then what do we do?
Take the derivative.
2,400
Minus,
minus 4y.
and then we set it equal to.
0.
Y equals 600. Good. 600. So, to find the other dimension, I plug it back into this one, right? So that's X equals 1,200. So it doesn't ask for the area, it asks for what? Bless you.
Dimension.
So my dimensions would be, it's in feet, so 1,200 feet by 600 feet. So the most important part too, just read the question. Sometimes it's going to ask for dimensions. Sometimes it's going to ask for the final area. What if it asks for the final area?
Then you multiply.
Then you multiply it. So my last class was having that issue. So just make sure when you do the homework that you just read the question. So the homework's on the back.
Oh, it is?